right, what is going on, guys? Mr. C here with lesson 10.4. Going to be talking about perimeter in areas of similar figures. If you recall, we talked about similar figures in a previous chapter. It's kind of like congruent figures, except similar figures didn't have to be the same size. They just had to be the same shape. So similar figures, different size, but same shape. Okay. So let's take a look at these two similar figures. I'll do two triangles. 2, 3, 4. Okay, we have this one here. Call this a 3, 4, and 5 here. And then we have this other one. We'll go 1, 2, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8, and we'll do connect. Okay, so let's say this is 6 by 8 by 10. Okay, if you recall, there's a term called scale factor. And if these two triangles are going to be similar, they'll have to correspond and go up by the same amount. So like by 3 to 6, that goes up by a scale of 2. We're multiplying by 2. 4 to 8, multiplying by 2. And then 5 to 10, multiplying by 2. So these are similar. And dividing their corresponding sides, if you did 10 over 5 or 8 over 4 or 6 over 3, you would get a scale factor of 2. Okay, comparing from going to the small one to the large one. All right. Now what we're going to be talking about is how do the perimeters relate and then how do the areas relate. So notice when we're talking about perimeters, oh, my buddy's crying upstairs. I don't know if you can hear that. It sounds sad. My son's crying. Anyway, let's continue. Perimeters. So if we are comparing perimeters, let's see, does that still have a scale factor of 2? What's the perimeter of this guy? Well, it's 4 plus 3 is 7, plus another 5 is 12. So for this one, the perimeter is 12. Let's see, this is 6 and 8 gives me 14, plus another 10 is 24. And notice something interesting about the perimeters is that they also have a scale factor of 2. Okay, also have a scale factor of 2. From 12 to 24, you're multiplying by 2. And that's going to be true for any shape. The perimeters, so we're going to call it, say, the ratio of perimeters. That's 24 to 12, which is also 2. And that's the same as scale factor. Okay, same as the scale factor, which is kind of interesting. Okay, same as the scale factor. Now, what's different is the ratio of areas. Okay, what I mean by that is, well, let's just find the areas, and I'll explain what I mean by that. The area of this guy. Okay, let's go with the area of the smaller one. Remember, that's base is 4 times the height here is 3 divided by 2. So 1/2 of 3 times 4 is a 12 divided by 2 is 6. Okay. All right, my next area is 1/2 of 8 times 6. Okay. 8 times 6 is, what is that? 48. Okay, 48 divided by 2 is 24. Okay, 24. So notice they don't have the same scale factor. 6 times 2, if it was going to increase by the same scale factor, is not 24. So how do we get that? Okay. Well, the ratio of their areas is, let's reduce this, is, what did we say, was 24 to 6. Okay, if I reduce that, that reduces to 4 to 1. Okay, now, and I'll write this as a 2 to 1. Okay, Notice these two things here, 2 to 1 and 4 to 1. So what's interesting is that these two are related, okay? Even though they're not the same, they are related. If you take the ratio of the perimeters and you square that, so for instance, this is, if you square that, 2 squared over 1 squared, that becomes 4 to 1, right? And this is going to be true for every shape. If you take the ratio of their perimeters, which again was 2 to 1, right? If you square that, so 2 squared to 1 squared is 4 to 1, that's going to be the ratio of their areas, okay? Their ratio of their areas. That makes sense. So again, scale factor, so from side length to side length, that's the same as perimeter, okay? We'll share the same scale factor. And then if you want to find the ratio of their areas, okay, that ratio is take the ratio of the perimeters or their scale factor. If you square it, that gives you the ratio of their areas. And we're going to use that to set up some proportions and stuff. We probably won't do any ones with proportions till tomorrow. Let's go ahead and try this first example over here. I'm going to need to take a picture. Give me 1 second. All right, so ignore the text because it's cut off. But look at those two trapezoids. Directions are find the ratio of perimeters and the ratio of areas. Okay. Find the ratio of the perimeters and the ratio of the areas. Now what's nice, in order to find the ratio of the perimeters, we don't actually have to find the perimeter for both. What we can do is just find the scale factor, which in this case is 6 to 9, and then that is the same as the ratio of the perimeters. So the ratio of perimeter, you know what, for the sake of time, we're going to call this the P ratio. That says ration. P ratio. Okay. Remember I said that is, if we're comparing them, 6 to 9. Let's reduce that. 6 to 9 reduces to 2 to 3. Okay, that's the ratio of the perimeters. Now, if we want to find the ratio of the areas, I'll say the A ratio. What do we do with the P ratio? We just square it. So area ratio is 2 squared to 3 squared, which is 4 to 9. Okay, 4 to 9. That is the area ratio. All right. I hope that makes sense. If not, let me know. I'll do my best to explain. Leave a comment, email, whatever you got to do. And that brings us to the end of Wednesday's lesson. We're going to continue on just in a moment. But if you want to stop here for Wednesday, go ahead, start with the homework for Wednesday. But if not, let's keep moving on. This is the beginning of Thursday's. Okay, beginning of Thursday's lesson right now. So, what can we do with this information? Well, let's take a look at this problem here. All right. Okay. It says the area of the smaller regular pentagon is about 27.5 centimeters squared. What's the best approximation for the area of the larger regular pentagon? Okay. So it says the area of this one is 27.5 centimeters squared. What could we do to find the area of the larger one? Well, they give us two sides. Okay, this is 4, this is 10. Those are comparable. So if we want to find the perimeter ratio, let's reduce that. Okay, reduce 4 to 10. That reduces to 2 to 5. Okay, reduces to 2 to 5. Now, we can't use that to just straight get the area of the larger one, but we can find their ratio of areas, which is good because I have what one of the areas is, and that will help me find what the second area is. So if I want to find the area ratio, remember we're squaring 2/5, so 2 squared to 5 squared is going to give me 4 to 25. Okay. That's the area ratio. Now what we can do with this ratio is set up a proportion with this area to find my larger area. Okay, so we know that 27.5 to whatever our other area is, okay, the area of the larger figure, we know that's going to be in the same ratio of 4 to 25. Okay, and make sure when you're setting this up, notice I have 4 on the top, okay, 4 being the smaller number. This area is the smaller area, so make sure that's on top on the left side when you're setting up your proportion. Okay, so again, 27.5 to the area of the larger figure is the same as my area ratio, which is 4 to 25. And recall we can set up or solve a proportion by cross multiplying. So we have a 27.5 times 25 equals 4a. Let's do 27.5 times 25. 27.5 times 25. I have a 687.5. So 687.5. This is equal to 4a. If we want to solve for a, need to divide by 4. So take that number, divide that by 4. Gives me a 171.875. 171.875. If you recall, I think it was a multiple choice question. 171.875 is my area for centimeters squared. And if we scroll up, what is the best approximation? So out of these, that would be the 172. Okay, should be my answer, 172. All right. Okay, so that's how we find one of the areas given one of the other area and their ratios. Let's do one more example. All right, let's take a look at this. Okay. The triangles at the right are similar. What is the scale factor? What is the ratio of their perimeters? And remember at the beginning of the lesson or the video, I said these are the same thing, right? So if you find the scale factor, that is the same of the ratio of the perimeters, all right? So it's pretty much asking the same thing. So this time they give us 2 areas, okay? So we're kind of working in reverse to what we did compared to the last problem. We're given the areas, so let's find the area ratio. All right, that's 50 to 98. Right. We can reduce that, so let's reduce that. 50 divided by 2 is 25. 98 divided by 2 is 49. All right, that's as far as that's going to reduce. So let's think, if I have the area ratio, if I go back, remember, to go from perimeter to area, we squared, right? We squared this number to get my area ratio. So if we want to reverse that, okay, let's say I want to get the perimeter ratio, okay? How do I reverse a square? We square root, right? So if we're moving from area ratio to perimeter ratio, you take 25 over 49, and we're not squaring, we're square rooting both of those numbers, okay? Square root those. And nice thing is those are both perfect squares, so this should reduce to square root of 25 is 5. Square root of 49 is 7. Okay, so that actually tells me the perimeter ratio, and that is the same as scale factor too. Scale factor. Okay, this is also 5 to 7, right? So that answers both questions. What is the scale factor? What is the ratio of the perimeters? It should be 5 to 7. So if you're given areas, find the ratio. To reduce it to get the perimeter ratio, you have to square root. You have to square root. Okay. And that brings us to the end of our lesson. Hope that makes sense. Let me know. Leave a comment. Let me know how it went. That'll be our last video for the week. On Friday, we will have our first progress check. It'll be on both lessons this week. So the videos from Monday, video from Wednesday. And that will be it. Again, those are due. I'll sign them Friday morning. And then those won't be due till the end of the day, Sunday. So you pretty much have the whole weekend to work on those. So that's it. That's all I have. Love you guys. Miss you. Stay healthy. Be safe. And we'll talk to you later. Peace.